Good afternoon, everyone. This is Marc Taylor, manager of Planetarium and Science programs here at the Hudson River Museum. Now, we wanted to do a video for Earth Day, some astronomical details of the orbit of the Earth, which actually affect how the Earth's climate changes. So let's say this is the Earth's orbit. This is going to be the sun, obviously. And many people think of the Earth's orbit as being a circle around the sun. It is almost a circle, not quite. It's actually an ellipse. Now, if you watch very closely, I'm going to change the actual circular orbit of this mythical Earth to the elliptical orbit of the real Earth. Ready? Okay, see a difference? Not much. Turns out that the Earth's orbit is basically a circle. It is an ellipse, but it's very, very close to being a circle. The Earth's orbit is an ellipse with the sun at one focus of the ellipse, so ever so slightly off to one side. Now, it's not always the case that the Earth's orbit is exactly this shape and in exactly this position. It changes in a bunch of different ways. One thing that changes is the actual shape of the Earth's orbit, the eccentricity. It changes from being more circular to being less circular. Again, actually less than I'm doing right here with this little hoop. But that change takes about 413,000 years to happen. So what happens is that orbit shape changes, and as that changes, that can affect the amount of radiation from the sun, which is striking the pole to the equator. The orbit changes in other ways too. The orbit itself also precesses. It precesses like this. One way to think about that is if you remember in the first Superman movie, remember when General Zod and the other two were in that little prison which spun around them? It's kind of like that. So the Earth's orbit precesses, and how this might change things is, for example, if you have the Earth and it's tilted toward the sun in one position, and then as the orbit changes, then it's tilted toward the sun, but it's in a slightly different position, so the radiation level hitting it is a different level, that will change it too. These effects are subtle and they all overlap. And that's not all, because the Earth itself changes too. The Earth, in fact, actually goes back and forth, so that if you were to take a look at the orbit of the Earth, that changes. But the tilt of the Earth changes as well. So sometimes the Earth is like this, tilted toward the sun. Sometimes the tilt is a little bit less. This tiny change right there, which is only a few degrees, takes about 30,000 years or so for that to happen, okay? And then there's another change too. Not only does it change like this, but over the course of about 26,000 years, the Earth actually wobbles, just like a top. So there's all these motions. The Earth's orbit is actually precessing. The Earth's orbit is changing shape. The Earth is changing its tilt ever so slightly, and also the Earth's axis is wobbling around in a circle. Now, all of those together are some of the changes which can affect the climate on the Earth. And it turns out that a Serbian scientist, Milutin Milankovic, what he did was he studied this change that can happen, all these changes that can happen, and he decided that he wanted to try to relate them to climate changes on the Earth. It turns out that you can relate them to climate changes on the Earth. His mathematical models were great, but it took until we actually had empirical information about those changes, about the actual climate, historical information from ice cores and varves and lakes. Putting all that information together, we discovered that he was right, and these very slight, slow changes do actually affect the climate of the Earth. Now here's the thing. These things do affect the Earth, and they do affect things like the onset of ice ages. However, in order for these changes to continue to affect things the way that they have, although people might say the Earth is going through these cycles and they're very long cycles and humans can't affect it, that's not quite true. Because what we think is happening is that we have put enough carbon dioxide in the atmosphere that in order for the next cycle, the next ice age to kick in as it was supposed to, according to these cycles, the level of carbon dioxide in the atmosphere would have to be roughly half what it is now. In other words, there's enough carbon dioxide and other gases that we have put in the atmosphere right now all around us to basically skip the next ice age. So before someone says that these cycles are natural, you should just expect them to happen and we can't affect them, that's not true, because we actually think that we have continued to affect them and we will continue to affect them. So, just some thoughts for Earth Day from the Hudson River Museum. This is Marc Taylor, manager of Planetarium and Science programs. Enjoy your day.